Good morning to all. Welcome to Chemistry Wala channel. Today I want to explain about molecular orbital diagram of oxygen molecule. By using molecular orbital energy level diagram, we can calculate bond order and its magnetic behavior. We know that the atomic number of oxygen is 8 and the electronic configuration of oxygen is 1s2, 2s2, 2p2. In O2 molecule, each oxygen atom is having 8 electrons. So, the O2 molecule consisting of total of 16 electrons. The filling of these electrons, are based on the above 14 electrons molecular configuration. That is sigma 1s, sigma star 1s, less than sigma 2s, less than sigma star 2s, less than sigma 2pz, less than pi 2px is equal to pi 2py, less than pi star 2px, pi star 2py, less than sigma star 2pz. Here sigma 1s, sigma 2s, sigma 2pz, pi 2px is equal to pi 2py. These molecular orbitals are called bonding molecular orbitals. Sigma star 1s, sigma star 2s, pi star 2px, pi star 2py, sigma star 2pz are called anti-bonding molecular orbitals. Generally the molecular orbitals are represented by the sigma pi, and anti-bonding molecular orbitals are represented by the sigma star and pi star. The bonding molecular orbitals are having the lower energy. That means the bonding molecular orbitals will be more stable. And the sigma star, pi star represents the anti-bonding molecular orbitals. These molecular orbitals are having the higher energy when compared to the molecular orbitals. The anti-bonding molecular orbitals are having the less stable when compared to the bonding molecular orbitals. Let us draw the MO diagram of oxygen molecule. Let us draw the MO diagram of oxygen molecule. Let us consider the two lines. These two lines representing the energy is in increasing order. The energy is in increasing order. From left hand side and right hand side, the oxygen atoms is taken. These two oxygen atoms are combined to form the O2 molecule. We know that the electronic configuration of oxygen atom is 1s2, 2s2, 2p, 2p4. It contains the O2 molecule. The O2 molecule is having total number of 16 electrons. Each oxygen atom is having the 8 electrons. 1s2, oxygen configuration 2s2, 2p4. In each oxygen atom is having the 1s orbital, and another oxygen atom is also having the 1s atomic orbital. The 1s atomic orbital are combined to produce the two molecular orbitals. One is bonding molecular orbital and another one is anti-bonding molecular orbital. The bonding molecular orbital is represented by the sigma 1s. Anti-bonding orbital is generally represented as sigma star 1s. 1s atomic orbital of oxygen contains the 2 electrons, and another one is also contains the 2 electrons. These 4 electrons are arranged in the molecular orbitals in the following manner. The atomic orbitals of the oxygen is having 2s atomic orbital is combined with the 2s atomic orbital of another oxygen to produce the two molecular orbitals. One is bonding and another one is anti-bonding. The bonding molecular orbital. The bonding molecular orbital is represented by the sigma 2s and anti-bonding is represented by the sigma star 2s. The 2s orbital contains the 2 electrons and another oxygen is also contains the 2 electrons. The four electrons are arranged like this in molecular orbitals. The 2p orbital is having the 4 electrons. 4 electrons. The 2p orbitals are the 2p orbitals are combined to produce the molecular orbitals. The lower energy molecular orbitals are called bonding molecular orbitals. These bonding molecular orbitals are having the lower energy when compared to the parental atomic orbitals, and the higher energy molecular orbitals are called anti-bonding molecular orbitals. The anti-bonding molecular orbitals are having higher energy when compared to the parental atomic orbitals. 2p orbital contains 4 electrons. Here 2p orbital contains 4 electrons. These 8 electrons are filled in the molecular orbitals basing on the Horn's rule, Aufbau and Pauli exclusion principle. The remaining 2 electrons are filled like this. This is about the MO diagram of oxygen molecule. The molecular configuration of oxygen molecule. The molecular configuration of oxygen molecule can be written as in the following manner from bottom to top. The sigma 1s contains 2 electrons. The sigma star 1s contains 2 electrons. Sigma 2s contains 2 electrons. Sigma star 2s is having 2 electrons. And this is the sigma 2pz is having 2 electrons. Pi 2px contains 2 electrons. Pi 2py contains 2 electrons. Pi star 2px is having 1 electron. Pi star 2py is having 1 electron. This is the sigma star 2pz is contains the no electrons. The molecular configuration can be written as from bottom to top. Sigma 1s2, sigma 1s2, sigma 1s2, sigma star 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2p z2, sigma 2pz2, pi 2px2 is equal to pi 2py2, pi 2py2, pi star 2px1, pi star 2py1, sigma star 2pz. This is the molecular configuration of the O2 molecule. Here sigma and pi represents the bonding molecular orbitals and the sigma star and pi star represents the anti-bonding molecular orbitals. The bonding let us calculate the bond order of the O2 molecule. Number of electrons in bonding molecular orbitals. These are the bonding molecular orbitals sigma and pi. It contains 2 electrons, 2 to 4, 4 to 6, 7, 8, 9, 10. The number of electrons in bonding molecular orbital is 10 and the anti-bonding molecular orbitals are generally the star indicates the anti-bonding molecular orbitals. Here 2 electrons. Here 2 sigma star 2s contain 2 electrons, 4, 5, pi star 2px 5, 6. Total number of anti-bonding electrons is 6. 10 minus 6 by 2. That is 4 by 2 is equal to 2. The bond order is 2. So the oxygen is linked with the another oxygen with 2 covalent bonds. With 2 covalent bonds, one is sigma bond, one sigma bond and one pi bond. Next, let us calculate calculate the magnetic nature. The O2 molecule is having the O2 molecule, the O2 molecular in O2 molecule, the O2 molecular orbitals is having the unpaired electrons, or single electrons. So the O2 molecule is having O2 molecule is having singular unpaired electrons. It behaves like paramagnetic nature. This is about the molecular orbital diagram of O2 molecule.